The evidence base available is limited with respect to bird collision and avoidance rates to inform impact assessments for new wind farm developments. A 2.5-year research study designed to obtain scientifically robust data about the behaviour of birds in and around an operational offshore wind farm is underway at Vattenfall's Thanet offshore wind farm off the North Kent coast as part of the Offshore Renewables Joint Industry Programme, ORJIP. Using state-of-the-art technology such as high-definition radar, thermal imaging cameras and laser rangefinders alongside trained observers, bird behaviour is being monitored at Thanet's 100 turbine wind farm. Rangefinder observations and radar tracking are recorded from 2 turbine platforms on the wind farm's eastern peripheral. One platform houses an X-band LAW-25 surveillance radar. The second turbine houses an X-band Scanter 5000 solid-state radar. Observers conduct rangefinder observations on both platforms, the operator able to fire at a target every 10 to 15 seconds to record distance and altitude, which are logged automatically via GPS. The combination of TADS camera system and a LAW-25 radar are housed on each of 2 turbine platforms within the wind farm. Each TADS camera system consists of 2 thermal night vision cameras and a dual-function zoom daylight, low-light colour TV camera. The camera software has been programmed to connect the camera with the LAW radar. As a result, when the distance to the bird target becomes less than approximately 1,000 metres, the coordinates are transmitted from radar to the TADS camera system, which will subsequently begin tracking the target in tandem with the radar. TADS camera system also videos the event. Each monitoring station operates independently of the others. Total avoidance can conveniently be subdivided into 3 scale-dependent avoidance rates, as defined in this slide. Data on macro avoidance is collected by observers using the 2 radars in the periphery of the wind farm and the laser rangefinders. Due to the expected range of macro avoidance displayed by several species of seabirds, the species identification of tracked birds is made by observers with telescopes. Data on species-specific meso-avoidance is collected by the observers using the 2 radars in the periphery of the wind farm along with the rangefinders, as well as by the combined camera and radars recording continuously from within the wind farm. Data on micro-avoidance and the collision events is recorded exclusively by the TADS camera system. Monitoring started in summer 2014 and early observations are promising in the aim to understand how birds interact with the wind farm. For all species combined, radar tracks with tandem observations from the observers equated to 72 records within the period July to November 2014. For the same period, laser rangefinder tracks from the 2 observer platforms equated for all species combined to 436 records. Likewise, tracks obtained by both TADS cameras and LAW radars equated to 808 records. The project has tested and validated the monitoring system to ensure the data being obtained are accurate and to demonstrate that the systems are capable of accurately detecting the birds' avoidance behaviours and their collision impact in variable conditions within a long enough period to collect sufficient data. Simulations of the collision risk calculations based on empirical data indicate that both the level and quality of collision estimates may be improved by application of the extended band model using data collected at Thanet. Early observations have provided confidence that sample sizes for the 5 key bird species will not be a concern to the project, with uncertainty shown in this slide's tabulation for micro-avoidance reflective of outstanding processing work. The results of this study will significantly improve our understanding of the collision risk of offshore wind farms to seabirds and consequently inform future consenting and development studies.